Okay, hey guys, let's go ahead and talk a little bit about trig limits. I got a little bit of feedback from some of y'all that your teacher hadn't covered trig limits yet, but from at least one of the BC kids, I got a notice that there have been some trig limits in their homework, and therefore they needed to know how to do them. Okay, now trig limits. While they look daunting, like everything that's trig, because everybody breaks out into a cold sweat when they're sine, cosine, tangent, secant, cotangent, but they're actually relatively simple, okay? If we just remember two things, well, three things. The first is some of them are very, very easy in terms of just plugging them in. Like any limit, if I have, the limit as x approaches pi over 2 of sine x, well, there's nothing indeterminate about that form, okay? Now, if there's nothing indeterminate about that form, then I can just go ahead and plug it in, okay? Now, what is sine of pi over 2? Well, sine of pi over 2 is 1, okay? And then you have like the limit as x approaches pi over 2 of tangent x. Well, if you remember tangent is not continuous at pi over 2. It has an asymptote. And of course, on either side of the asymptote, on the negative side of the asymptote, it goes to positive infinity. On the positive side of the asymptote, it goes to negative infinity. So this limit doesn't exist. And all I needed to know about that was just the nature of tangent itself. There was no identity. There was nothing special. It was just rather straightforward. Now, what happens is we get into a little bit of a sort of deep end when we have the limit as x approaches 0 of something like sine of 3x over tangent of 2x. And this is the kind of problem where we wind up breaking out into cold sweats, okay? And it's here, this type of problem, that we need to remember, or we need to know, I don't know if I discussed this with y'all last year or not, we need to know two trig identities for limits. The first one is the limit as x approaches 0 of sine x over x is equal to 1. And those of you in the BC class that watched the video on the proof of this identity already know it, or at least have seen it before. The limit as x approaches 0 of 1 minus cosine x over x is equal to 0. Now those are two identities that need to be remembered, okay? And it's something like that that's going to help you with this one. Now we're not going to jump straight to something like that. But we'll get there, okay? Now, what we need to do is we need to go ahead and start with something a little bit easier. Let's say we have the limit as x approaches 0 of sine of 3x over x, okay? Now, this looks similar to this, okay? But it's not the same. And from here, what I need to know is that really it works for any coefficient of x so long as the coefficients in the numerator, in the angle measurement expression, and the denominator match. So sine of ax over ax. Now, that in and of itself is not equal to 1, and we got to be very, very careful about that because we're so used to identities involving trig that don't involve limits that we all of a sudden think that sine x over x, or sine 2x over 2x, or sine 3x over 3x is automatically 1, and it's not, okay? It's only the limit as x approaches 0 of sine 2x over 2x is equal to 1, and the limit of x as x approaches 0 of sine 3x over 3x is equal to 1, or the limit as x approaches 0 of sine 17x over 17x is equal to 1, okay? But here's the problem. These coefficients don't match. I have a 3x up here, and I have an x down here. Well, we simply need to change the form. If those coefficients don't equal each other, we make them equal each other. We go ahead and put a 3 down here in the denominator. But if I do that, I've changed the form, haven't I? I mean, I've changed the value. I haven't just changed the form, I've changed the value. I've divided by 3. So in order to make sure that I do this in such a way that I have not changed the value, I need to then multiply by 3. I've multiplied by 3, I've divided by 3, so I've functionally multiplied by 1, okay? And therefore, what's inside of these brackets is 1 times 3, and the limit, of course, is equal to 3, okay? And so we can come back up here and actually start to think about this one right here. Now, what we need to do so we need to know that first things first. I told you there were going to be 3 things, right? So the first thing that I said is, just like any other limit, when we approach it, the first thing we ought to think about is actually plugging it in, okay? And we can't get into sort of like habitual rhythms, because there was a time when I actually put this on a test and people told me that it was 1. Well, that's not 1. It's only the limit as x approaches 0 of sine x over x that's 1. This is the limit as x approaches pi over 2 of sine x over x. Well, that you can just plug in, right? That becomes 1 over pi over 2, or 2 over pi, okay? So be very, very careful that you can just plug in. So the first thing that we did up here was we evaluated with no tricks, right? This is sort of a no-trick evaluation, and that's the first thing we need to go ahead and look for when we're approaching any limits, even when we're doing trig limits. Then we got to this one, and we go, okay, well, I need a little bit more. And so the second thing that I told you was those identities, okay? And then we did a quick example. Now, how does this actually wind up helping us in terms of that original nasty one, which first led us to the conclusion that we needed those identities? Well, if I have the limit as x approaches 0 of sine of 3x over tangent of 2x, I obviously need to change the form, because it is not yet in a form that has sine of ax over ax. But I can change the form by taking this product, and remember, because we've always talked about the fact that multiplication and division are secretly the same thing, we need to pull this apart strategically such that it actually reveals factors that are helpful to us, okay? Now, I happen to know that tangent of 2x is sine of 2x over cosine of 2x. So let's see how that helps us. Now, I'm assuming that your teacher has been over the limit laws, okay? Now, the limit laws, one of the limit laws states that the limit of a product is equal to the product of the limits, right? And I'll show you how that works out here in just a second. So we have the limit as x approaches 0, and if I want to simplify this right here, I can go ahead and divide by that the reciprocal of what's in the denominator, and I get cosine 2x, sine 3x, and sine 2x. Okay, well, that's a little bit nice and neater. So let's go ahead and actually start pulling it apart now. Okay, now I know that if I want to deal with this sine 3x, I kind of have to have it by itself. And then I can deal with this cosine 2x. And then I can deal with this sine 2x. And I want to pull them apart into distinct factors. Well, now I know that in order to take the limit of this particular factor, I need a 3x in the denominator. Oh, well, let's not worry about the 3 right now. Let's worry about the x, right? I need an x down here. Well, can I put an x down there? Sure, if I go ahead and put an x up here, I've multiplied by x, I've divided by x, I functionally multiplied by 1. That's why you learn the multiplicative identity property. Therefore, I've multiplied by 1. Now, I need a 3 down here. But 3 doesn't belong anywhere else in here, so I'm going to pull the multiplied by 3 out in front. I'm going to put a 2 here, and I'm going to put a 2 in the denominator out in front. Therefore, functionally, so far, I've multiplied by 3, 2, and x, and I've divided by 3, 2, and x. So I functionally multiplied by 1. Now the question is, what do I do with cosine 2x? And the answer is nothing. As a factor, that is capable of being evaluated just by plugging in, and therefore I don't do anything with it. Now, remember when I told you that the limit of a product is equal to the product of the limits? So you can rewrite it, though I don't understand why. Once you understand the principle, you won't need to rewrite it. This is equivalent to that. Okay? Okay, well, that's easy. Well, this is 3/2. 3/2 remains 3/2. What is the value of this? Well, we set it up and we strategically changed the form such that the coefficients match. So now that is 1. Okay? Well, this one we can go ahead and plug in. Cosine of 0 is 1. The question, but that's flipped over. Okay, well, what's the reciprocal of 1? 1. So that winds up being 3/2. Okay? So the three things that you need to know in terms of trig limits are these. Number 1, try to plug in. It might actually be capable of being evaluated right from the get-go just by plugging the approach value in. Number 2, you need to learn those two IDs. Okay? And you need to apply them. Okay? And in applying them, especially with one like our last example that was multiple factors that had to be manipulated and changed in form, we need to understand the limit laws. Okay? And the limit laws, I can review those, but it's really not worth it. First of all, because they're in your book and they're very, very straightforward and intuitive. Second of all, because your teacher has probably already gone over them. But basically it's, the sum of two limits is equal to the limit of a sum, and vice versa. The product of a limit and the limit of a product are the same, and are the same thing, right? The limit of a quotient and the quotient of two limits, those are going to be the same thing, okay? So you need to go through the limit laws, because oftentimes we need to take these two IDs that we learned and apply them within the context of limit laws. And beyond that, there's really nothing that you need to know how to do, because all that's left is algebraic manipulation that you're already familiar with, right? I mean, what did we do up here? I mean, we're doing it with trig factors, but pulling variable expressions apart into constituent factors is an algebraic move, right? It's something that we learned in Algebra 2. We went back over in pre-cal. It should be understandable to us, at least, even if we've sort of forgotten the contours of it. We need to be able to take apart, we need to be able to take products and quotients and pull them apart into their constituent factors such that we can actually manipulate those individual factors into the form that the two IDs actually hold, okay? That's sort of the conceptual backdrop for trig limits. I'll go ahead and stop the video here, and I'll basically pull out, about a dozen or so examples, and we'll run through those very, very quickly in the next video that I post.